Now let us analyze series RL circuit across an AC EMF. In this situation you can see a resistance R and an inductor L. Inductance is connected across an EMF which is E0 sin omega t, of which the phasor form is written as E phasor E0 angle 0 degree. Now if we wish to calculate the current phasor in the circuit, here we can first calculate the impedance of circuit is, as RL and L are connected in series, we can write its impedance is R phasor plus XL phasor, which can be written as R angle 0 degree plus XL is written as omega L angle plus pi by 2, for which if we draw the impedance triangle, this is called impedance triangle because here we are taking resistance at 0 degree on organ plane, and XL we consider as omega L at plus 90 degree, and for these two phasors if we add the resulting impedance phasor Z, we can write as in magnitude R square plus omega square L square, and is at an angle theta, where theta we can write here as tan inverse of omega L by R. So from these relations we can see the impedance phasor here is root of R square plus omega square L square angle tan inverse of omega L by R. And by Ohm's law we calculate the current phasor in circuit. Current phasor can be written as the EMF phasor by Z phasor by Ohm's law. It is EMF divided by the total ohmic opposition. If we substitute the values here, you can see this E0 angle 0 degree divided by this root of R square plus omega square L square angle tan inverse of omega L by R. And here we can see the current phasor we are getting is E0 by root of R square plus omega square L square and angle 0 minus tan inverse omega L by R. So if we calculate the time function, if we write the time function by using the phasor form, time function of current we can write as E0 by root of R square plus omega square L square sine of omega t minus tan inverse of omega L by R. This is the time function of the current which is flowing through a series LR circuit. And here you can see the current is lagging behind the EMF. If we consider this as equation 1, this as 2, we can see current is lagging behind EMF by an angle tan inverse of omega L by R. This we can directly explain that the resistance has a tendency to keep the current in same phase with that of EMF, and inductor has a tendency to lag behind current by an angle pi by 2 with respect to EMF. So due to the efforts of both of these, the current is lagging behind, but this value, which is tan inverse of omega L by R, will be less than pi by 2 but more than 0. 0 is due to resistance, pi by 2 is due to inductor. So because of both R and L, the overall impedance has some inductive section. Due to this section, what happens, the current will lag behind, but due to resistance it will not lag behind by pi by 2, it will be somewhere in between. And that's why the result we are having peak value E0 by root of R square plus L square with some lagging behind initial phase. If we draw the impedance triangle, we have obtained this by R, omega L and Z. We draw the phasor diagram for this particular case. We can see EMF will be at an angle 0 degree, but in this situation if we draw the current phasor, this I0 will lag behind by an angle theta, which is given by this value.